So good morning students. In today's lecture we will see two triggering techniques for this gate junction of this thyristor. So as in my previous lecture I will discuss the gate characteristic between VG and IG. This is a gate voltage and this is a gate current. So in previous lecture we will see this whole explanation of this VG IG characteristics, gate triggering characteristics of thyristor, and some points regarding to these characteristics. Now we will see the gate triggering methods. So there are two methods. First one is the continuous gate triggering method. So this is the method in which if on the turn on time of this SCR, we will not remove our gate signal even after the turning on of the SCR. So continuous gate power loss occurs. This is unfavorable condition of triggering. So as we know, gate pulse is necessary to turn on the SCR. But if we not remove gate signal even after the turning on of the SCR, then continuous gate power losses happens across the gate cathode junction of the thyristor, which is the unfavorable condition of triggering. So complete damage of the junction occurs if we not remove the gate signal even after the turning on of the SCR. So this IG gate signal versus time is drawn, in which we can see that this gate signal is continuously applied, is the magnitude of IG, and VG is also there because due to this VG IG current is flowing. So if you want to calculate this PG average, which is the average gate power dissipation, then it will be given as VGIG, and this is the average value. So we can simply VG into IG, maximum value, take the maximum values. So to calculate the peak average power, this is a PG maximum. So PG maximum here is similar as that of PG average in this case. So this expression is very important for the numerical point of view. So PG average can be calculated as a VG into IG, simply multiplication of this, and this is the maximum amount of power because this current is a maximum value and also VG is there. So if we multiply this, we can obtain the PG maximum. So this type of technique is preferred in the highly inductive loads. Why? Because if we write its expression across the inductor, VL equals to L di by dt. So in this expression, if we increase the L to on the higher side, then time of the triggering is also increases. So time of triggering is increases means the continuous gate triggering will be there across the entire this pulse width of duration t. Even after the t, this is a continuous turn on, so this gate signal is continuously applied. So this technique is used in the highly inductive load cases. Now we'll see the second type of triggering method, that is known as the pulse triggering method. So thyristor is considered to be a charge control device. We know that thyristor is a charge control device because IG current is there, and thus higher the magnitude of gate current, if higher the magnitude of gate current pulse, lesser is the time required to inject the required charge for turning on of the SCR. So if the gate signal which is DC quantity, if it is a larger current pulse having higher amplitude, so time to inject this higher amount of charge is the less amount of turning on time is required. So this is a must condition. Therefore SCR turn on time is reduced. So SCR turn on time is reduced if you apply the current signal having large amplitude, but it should ensure that pulse width is sufficient to allow the anode current to exceed the latching current. So latching current is basically turn on related turn on process of the SCR. This is the minimum amount of gate current which will be required to turning on the SCR. So this current pulse having amplitude of greater than latching current to turn on the our SCR. So this condition is must, that pulse width is sufficiently to allow the anode current to exceed the latching current. So in this is a gate current which is drawn versus time. So in this this is applied in the form of pulse. So up to t on time the gate pulse will be applied, and for t of time it will be in off condition. This is a whole period of time t, and after t time it is again repeated. This is again applied gate signal to the this our SCR gate terminal. So in this uh, we can calculate the PG maximum, which is VG into IG, because this IG amount of current will be passes and VG amount of voltage will be there across the gate terminal. So PG maximum can be calculated as VG into IG, which is the gate power dissipation. So it's the PG maximum. It is same as that in case of this continuous gate triggering. But the condition in the pulse triggering is that this PG average, which is the average gate power dissipation across the gate cathode junction, which is always less than the PG maximum. Why? Because if we calculate this PG average, average means area under the curve. So this PG maximum is a PG maximum, and this is the turning on up to T on time out of T time. So T on divided by T. So as PG maximum, if we put PG maximum from the this VGIG here, then it can further simplified VGIG the T on into F, because this F is equals to 1 by T. So this is the expression. So this is a condition for this pulse get triggering. So here T on upon T is the duty cycle. So duty cycle is always less than 1. So if we multiply this PG maximum, so then PG average is also always this is less than or equal to PG maximum. So if in the problem, if PG maximum is higher than PG average, we can see that this is the pulse triggering condition. So this condition is very important for the numerical point of view. Now we will see the some of the point regarding these two techniques. Pulse, practically SCR triggering is done with the 10 kilohertz. So higher amount of frequency will be there for triggering the SCR. So higher amount of frequency means higher carrier frequency will be there. So higher frequency is there. So higher amount of this pulsation are there with periodicity. So hence T is equals to 1 by F. This is the time period. So if we calculate this time period, this is 100 microsecond. So if our T on, which is the turn on time, is less than the 100 microsecond, then pulse get triggering will be there. So if in the next class we will solve the numerical problems regarding to this, in which we can see that if 10 this turn on time will less than 100 microsecond, this is the pulse get triggering method. And in this technique, PG average is always less than the PG maximum, and it can be calculated by using this formula which is discussed above. And second one is the T on is greater than 100 microseconds, so it is a continuous gate pulse triggering method. If our total turn on time is always greater than this whole amount of duration T, 100 microsecond, then it is a continuous pulse triggering method, and in which PG average can be calculated by VG into IG. So this is the all about this two types of triggering methods for the gate junction of the SCR. So in the next class, we will see solve some numerical problems regarding to these two types of triggering methods. Thank you.